Arithmetic sequence review. So we need to find the next three terms and describe the pattern. So sequences are basically just patterns. That's all they are. So to find this pattern, we're going to see how far is it from 1 to 3? Well, it's 2. How far is it from 3 to 5? It's 2. How far is it from 5 to 7? It's 2. So that pattern is we're just adding 2. So those next three numbers are going to be 9, 11, and 13. Because 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. Okay, if we look at example B, that's adding 5. And if you struggle with finding that, you can always do the second term. So we can find this term and subtract the first term. So we could do 18 minus 13. You get 5. Could do the same thing, 23 minus 18, you get 5. 28 minus 23, you get 5, blah, blah, blah. Okay? So on. So we're adding 5, which means the next three numbers, 28 plus 5 is 33, plus 5 is 38, plus 5 more is 43. Okay? Look at example C. 7 minus 3 is 4, so you can also subtract. 4 minus 3 is 1. 1 minus 3 is negative 2. Minus 3 is negative 5. So we're going to keep subtracting 3, which means we get negative 8, negative 11, negative 14. Okay, this next one, if you don't know how far apart those are, you could always do negative 15 minus negative 22. You get positive 7. So you add more 7, add 7 more, add more 7, sorry. 1 plus 7, negative 1 plus 7 is 6. 6 plus 7 is 13. 13 plus 7 is 20. Okay? Now, an arithmetic sequence is a sequence of numbers such that the difference between consecutive terms is constant, and we call that the common difference. Okay, and we use many symbols when referring to this sequence. D is the common difference. A sub 1, or A1, is the first term. So like if that was A2, it would be the second term. A4 would be the fourth term, so on. AN, so A sub n, is the nth term, or any term. And then A sub n minus 1 is the term before the nth term. Now, the subscript is called an index and indicates what term you're referring to. So, A sub 12 refers to the 12th term. A 35 refers to the 35th term. Okay? So here, we need to identify our D. So we need to identify the common difference and the first term. Then we have to find the term indicated. So in this first one, let's first see how far apart are 3 and 9. 6. 6 more, 6 more, 6 more. So the common difference is D, which is 6, and the first term is 3. Now to find the sixth term, I'm going to add 6, you get 27. Add 6 more, you get 33. Okay? Now on this next one, to get to 8, from 8 to 1, oh, sorry, so the sixth term is 33. Subtract 7, subtract 7, subtract 7. So the difference is negative 7. The first term is 8. We need to find the 10th term. So I'm going to do negative 13 minus 7 is negative 20. Minus 7 is negative 27. Minus 7 is negative 34. Minus 7 is negative 41. Minus 7 is negative 48. Minus 7 is negative 55. So the 10th term is negative 55. Okay. You do examples C and D. You should get, you should get 43 and negative 52 when you do them. Okay? Now, the recursive formula for an arithmetic sequence is A sub n, so whatever term you're trying to find, equals A sub n minus 1, so the term before it plus the common difference. So any term is the term before it plus the common difference. So for the following sequences, we're given the common difference, we're given the first term, we're asked to write a recursive equation for the sequence, and then write the first 5 terms of the sequence and find the term indicated. So this recursive equation is a sub n equals a sub n minus 1 minus 3. That minus 3 is really the only thing that ever changes in this. Okay, so the a sub n and a sub n minus 1 will always be the same. Now we can find the first 5 terms. I only found to number 4. I don't know why. That next term would be 1. That's going to go away. But so we just, the first term was 13, so 13 minus 3 is 10, minus 3 is 7, minus 3 is 4, minus 3 is 1. And then a to the fourth, or the fourth number, whatever, the fourth term is 4, so a sub 4 is 4. Now on this next one, the recursive equation is a sub n equals a sub n minus 1 plus 10. We're asked to find the 7th term, so we're going to do 16 plus 10 is 26, plus 10 is 36, plus 10 is 46, plus 10 is 56, plus 10 is 66, plus 10 is 76. So a sub 10 is 76. Save these next examples for class. Let's do this one. So for the following sequence, you're given the recursive formula and the first term of the arithmetic sequence. Write the first 5 terms of the sequence and find the term indicated. So my common difference there is 4. And the first term is 10 because that was given to me. So I can do 10, 14, 18, 22, 26, 30, 34, 38, so on and so forth. And so a sub 3 is 18. Okay, on B, my common difference is negative 7. My starting number is 0. So it's going to be 0, negative 7, negative 14, negative 21, negative 28, negative 35. And a sub 6 equals negative 35. So the 6th term is negative 35. Okay? Save these last 2 examples for class. Let's flip this over. So the explicit formula, because it gets kind of annoying to add and subtract all these numbers. So there is a way to do this. Like if we have to find like the 90th term or the 100th term or whatever it may be, you can use a sub n equals d times n minus 1 plus the first term, which is basically any term can be found by adding the common difference times 1 less than the term you're looking for to the first term. Okay, so we're going to use the explicit formula given to write up the first 5 terms and then find the term indicated. So on this first one, my first point, or my first term is 6, and the common difference is 2. And I'm asked to find a sub 20. So that's going to be 6, 8, 10, 12, 14, and so on for those first 5 terms, because you just take 6, add 2, add 2, add 2, add 2. Now we're asked to find the 20th term, and we could do that by adding all this, adding 2 a bunch more times, or just plug in 20 into where that n is. So we have a sub 20 equals 2 times 20 minus 1 plus 6. Plug that into your calculator and you get 44. Okay, let's do this next one. So my first term is 15. The common difference is negative 5. So those first 5 terms are 15 minus 5 is 10, minus 5 is 5, minus 5 is 0, minus 5 is negative 5. Now I'm asked to find the 72nd term. So that's a sub 72 equals negative 5 times 72 minus 1 plus 15. Plug it into your calculator, you get negative 340. Okay, we're going to save those examples for class. Now on these ones, we have to write the recursive and the explicit formulas, and then we have to find the term indicated. So first we need to figure out what is my first term and what is my common difference. So from negative 24 to negative 16, you add 8. And you can keep adding 8, which means my common difference is 8, and my first term is negative 24. So my recursive formula here, we're asked to find the 32nd term. So that's going to be a of 32 equals a of 31 plus 8, so plus the common difference. And if you wrote that as a sub n equals a sub n minus 1 plus 8, that's also fine. I really don't care. Okay? And then the explicit formula is a sub 32 equals 8 times 32 minus 1 minus 24, which equals 224. So the 32nd term is 224. Okay, let's do B. So the common difference there is negative 9. So my difference is negative 9. My first term is 22. So the recursive formula is a sub 21 equals a 20 minus 9. And the explicit formula is a 21 equals negative 9 times 21 minus 1 plus 22, which equals negative 158. Okay, this stuff really isn't that bad. Save these last two examples for class. Remember to take the quiz. I will see you tomorrow.